Welcome back to the SolidCAM mill turn training sessions. In the previous video, we set the initial primary alignments for the coordinate system. Now what we're going to do is make definitions for our target and our stock models. Let's start with the stock first. The stock is the material or the size of the material that you're going to be machining the part from. When you go in and select stock, there are a few different ways that you can select or build your stock. If you're using some of the defaults, you can pick standard cylinder, box, revolve boundary around a Z, extruded boundary, take a profile and extrude it to represent the shape and size. You can also use a 3D model. So if you're using castings or forgings, you can have your as cast or as forged models representative in the project and pick it directly from the environment. In this case here, I don't have any stock defined or in my project. So I'm going to define my stock by a cylinder. And when you're describing a stock by a cylinder, you can define it either by keying in the absolute dimensions for the stock size of the starting material. So you can give it how much material is sticking out from the front of the part, how much is to the left of the part to hold on to, the diameter and internal diameter if you're dealing with a tube. In this case, I'm going to go relative to model, and I'm going to have it add these dimensional values to the size and scope of the project that I pick. So when I say relative to a model, it's going to build a cylinder and it's going to add these dimensional values to it. So when I pick the model, it will go ahead and build that stock at that representation. If I wanted to see what it looks like, I'll hit the show button and the show will show me a picture of what the stock kind of looks like. Now if you notice these facets here on the perimeter of the part, down here at the bottom as well, you have a facet tolerance, and this is a simulation tolerance. So if I were to set this to like 0.05 of a millimeter and show it, you'll see that those facets are reduced. So it's just for visuals and graphical representation when we are doing simulations, but it can give you a better simulation result. When I accept out of building the stock, what is going to happen is it's going to take and it's going to build me a wireframe, okay, that I can use for programming this later. But we'll see here we have a check mark defined, meaning our stock definition is now defined. I'm going to do the same thing with the target model. When I come out and pick the target model, here's our facet tolerance again. Again, this is a simulation tolerance. And what this will do is when I pick the solid and accept this, it'll say parsing the model, and what this is actually doing in the background is it's spinning the part and it's building me again a wireframe cross-section representation of what this part looks like spinning. So if we look here at that light gray silhouetted boundary, it steps up down into the groove over the top, and you'll notice some differences here on this back face. It wasn't able to, it thinks that there's stock there. Well, in reality there actually is. Not all these surfaces on the back are straight walls, some of them are angled, and it's giving you an accurate representation of what this part looks like spinning. I'm going to go ahead and I'm going to accept this and accept out. We have all the definitions defined for coordinate system, stock, and target, and now we're ready to start putting tool paths down onto our part. Thank you for watching, and please continue watching for the next series of videos.